Friends, we are privileged to have Professor Krishna Misra, ma'am, amongst us. Ma'am is actually she's from University of Allahabad, and now she is one of the senior most professor, and she is actually blessing us with her all the blessings and advices upon us, and in the triple ITA. And we are fortunate to have her, ma'am. Thank you for giving your precious time, and she will be talking about something related to Ayurveda and like how to improve your immunity. Am I right, ma'am?
No, this was last time I spoke about, so I thought I
Okay,
should
ma'am.
not repeat. I'm
Okay,
talking
ma'am.
about challenges and fascinations in the study of science and technology.
Okay, so ma'am will be talking about challenges and uh,
Fascinations.
fascinations. Okay, in science and technology. So, ma'am, the stage is all yours, and they are your students only, so you know them. BTech first year, and we are organizing this camp as orientation camp for this BTech first year, just to provide them some kind of orientation with respect to the different fields of life, which will help them in building their life in future, because they should not only know the coding part. They are the very good coders, but they should have some idea about the life skills and about the society and about the country also. So that is the whole objective of organizing this orientation camp. So, ma'am, the stage is all yours. Please, ma'am.
Thank you. Thank you, Dr. Ranjit Singh, for your introduction. Very good morning to all the faculty and students present here, my dear students. You are all my grand generation, and I thought that I should talk to you uh, about what is the future in the country, because all of you are science students, and science means knowledge. Verbal meaning is knowledge. So knowledge can be applied for technology, and technology should be innovative. Now, with that idea, I thought that I will uh, talk to you today about what are the hot topics now for which you can uh, go for study in future. So I'm grateful to organizers for giving me this opportunity. Let me share the PPT with you. Okay, now I'm going to talk to you about some challenges and real fascinations in the study of science and technology. So I think you will all be interested to know as to what are the challenges in the future and real fascinations. You will find that there are real fascinations in the study of science. Now, committed, science, you have to be, if you have taken up the field of science and you are going to develop technology, I think you have to be very much committed. And without committed to scientific advancement and innovation, this word has been added to by our government in 2010, I think in Indian Science Congress, this was thought that along with science and technology, the word innovation should be added in the national policy. So without innovative technology, we can't move forward as a society. So at national level, international level, we have to go forward and we have to innovate technology. Well, science, as you know, unlike any other subject, science is global. All of you know that whatever you learn in science is applicable all over the globe. So science knows no country, because knowledge belongs to humanity and is the torch which illuminates the world. this was said, this is quoted by Louis Pasteur, as long back, centuries back, still we remember Pasteur, we call pasteurized milk, pasteurized food, So he was the inventor for what you call as fermentation enzymes. So, you know that whatever you learn here in India, same thing other students are learning all over the globe. So science knows no geographical division. All of you recognize him. He's the very well-known Dr. APJ Abdul Kalam, former President of India, the great scientist. So he said, while speaking at 11th International Conference on Public Communication of Science and Technology in New Delhi, he said that the lesson we derive out of experience is that innovative and student-friendly solutions are needed to enable scientific learning in the youth, especially those in rural and remote regions of the nation of the world. So these were the golden words said by our dear Dr. APJ Abdul Kalam. And we know that now this generation, your present generation, should carry his words forward. There are lots of challenges in science. All of you know that how things are manufactured, whether they are drugs, whether they are polymers, whether they are anything which is manufactured by industry, they start with some raw materials. They use certain processes. They are chemical processes, maybe they are now biotechnological processes also are used. So how do you make things on a larger scale? And that too pollution free. That is important. So how these particles are moving and how different plants, animals, there is a lot of biodiversity in this globe, and how they communicate with each other. They coexist, the human, the animals, the plants, the microorganisms, all of them coexist together. So how they communicate with each other, how germs develop, how you get flu, now COVID. All of you know that you are gaining knowledge about these viruses also and how other ailments occur. You are all interested to know about the reasons. There are lots of fascinations in science, finding vaccines. During this COVID time, all of you know that how much hue and cry was for vaccines. And I am happy to tell all of you that India has shown to the world its own potential, that how much, because they have the pharma companies here, they have produced vaccines which has established a global record. So we are proud of them. So finding vaccines for so many diseases, not only COVID, but it's any virus, bird flu, dengue, hepatitis, malaria, then, initially smallpox and so many things, then how, and cancer is one disease, so much research has gone into it, but still there is no permanent solution. So let's see what is the reason. It's very fascinating. Then you see, learn about that man has walked on moon. Now, don't you want to know that how about other planets? Is there any world like ours there? जैसे कहते हैं मंगल पे लाइफ है, कौन से ग्रहों पर पानी है, वहां लाइफ हो सकती है. So much, this is so fascinating. Wouldn't you like to know all and study the mechanisms of all these processes? Of course, you will be interested. So the very thing is that as scientists, I must congratulate all of you, the fresh students who have come to learn technology here, that you can do a lot for benefit of humanity. And that is what is expected from you. I'm giving you some examples because you are almost of this age, that Alexander Graham Bell, you must have heard very well, when he started experimenting with sound, he was only 18 years old and he discovered telephone. When Charles Darwin thought about biodiversity, he was attracted towards biodiversity. How many types of plants you see, how many types of animals you see. He was also of your age, only 18 years, and started inquisitiveness for marvels of nature. And he discovered theory of evolution. So, my dear students, it's your chance now. Just have fun with science and innovate. Now, let's see the global scenario. What is happening all over the world? Because science is global. The greatest strides have been made in electronics, biotechnology, and nanotechnology. If you see the last half a century or 1 century, lot of this thing has come in electronics. If you look at the global scene, then last century, lot of discoveries in electronics like microprocessors, fiber optics, satellites, television, telephones, computer information, medical instruments, so much has come. And biotechnology, I think this has a very, very wide umbrella. And in biotechnology lies the future of humankind. Nanotechnology has now come. Nanotechnology, nano level, at atomic level, you can work with matter. How fascinating it is, A lot of science goes on that we never know about. But sometimes an experiment comes along that makes us rethink our ideas about the world. Now, I give you an example here. As I said, that you have to be committed, not only committed, but you have to have a curiosity to know about things as a scientist. Now, the example, all of you must have heard the name of penicillin. Penicillin was the first antibiotic discovered, and it worked for 50 years. That was the first antibiotic which was so effective. Of course, now it has become, it doesn't respond because that happens with every drug. But you know how it was discovered? There was a scientist by name of Fleming, and he was a microbiologist. He was culturing bacteria in his lab, but he had to go on holiday. So as it happens in labs, they collect all apparatus, put it in the sink to wash. He had no time to wash and he left just like that. When he came back after some time, what he saw, because if it had been any other person, without looking, they would have washed. But he was a real scientist. He looked that on one of these slides, on which he had grown bacteria, fungus had grown. All of you must have noticed in your houses also, any food material which is kept for a long time, fungus grows on that. No. So he also saw that. Anybody else would have just noticed and just washed it. But with a scientist eye, he looked that what is this? This fungus, wherever the fungus had grown, bacteria had lysed. So he thought that this fungus must be having something which is eating up bacteria. So he just took it from the slide and worked on it and discovered penicillin. That helped society, that helped the whole globe for 50 years. So that is how science goes. Now, all of you have come to learn science. You are going to become technologists. So I wanted to tell you what sort of thinking, what sort of mindset you should have. Like Fleming, you should have curiosity to investigate in depth. You have to be a good organizer. Then patience. Science needs patience because every time you don't get positive results, most of the time you may be getting negative results, but those negative results also lead to wonderful discoveries. Aptitude for good expression in speech and writing. You should be a good orator and a good writer without grammatical mistakes. So this is what you have to learn. You should have ability to work in a team. Hard work, total commitment. You know, I did my PhD in chemistry long back, 1958, when I think your parents also must not have been born. And my professor, you know, the famous professor Padma Vibhushan T.R. Shishadri, he used to tell us that think about chemistry all the time. Think chemistry, sleep with chemistry, dream chemistry, and then only you can become a scientist. So that is what you need in science. By carrying out research in any subject, you leave a legacy for the world. And as I told you, it's global. So whatever you are informing to the world, it will be available, it will be applicable everywhere, all over the world. So there is no need for plagiarism. You can't do plagiarism in scientific work. You know, you have to be creative. You have to be open to discoveries. Now, all of you know that our government has started a new education policy in 2020. And you should all be aware of the new education policy, and that emphasizes on innovative research and critical thinking in higher education system so that our country is converted into a knowledge superpower. Now, I wanted to tell you what is innovation. Innovation, we are using this word, so you should be very clear about the meaning. Innovation means any product, innovative product should be desirable to users. Everyone should be happy to use it. What is possible with technology, what you can create with technology, and what is viable in marketplace. The best example is mobile, you know, because mobile now, everyone has a mobile, they need mobile. So, and it's possible with technology, it is dispersed in society. There are many other examples also. So that is what is innovation. You all are technologists, so you should know that, as I have already said, that science means knowledge and science leads to invention. You know, there is difference between invention and discovery. Discovery is what is already exists and it is not known. But invention is something that out of discoveries you create something new and you apply this knowledge and innovate something very, very new, innovative. That is technology. And technology then diffuses in society. So these are the three phases of technological change. All of you are technologists, going to be technologists. So remember this. Now, country's empowerment, because all of you should be working for benefit of the country. Whatever you do, think that how you are going to help the country. You know, people feel that we pay the fees and so we are entitled to get knowledge, you know, but you don't know how much government spends on you. How much, and that is public money. So you are spending public money on your education. So you owe something to the country. You have to give back to the country. So no nation can achieve any sort of independence, whether cultural, whether social, whether economic, without science and technology. Nothing is possible. So whatever major problems India is facing, that these have to be solved through IT, electronics, biotechnology, and nanotechnology. Majority of population is rural population, so we have to think about rural technology. Now let's see what are the major issues facing India. We have problem of drinking water. We have problem of malnutrition, hunger, health, pollution of the environment, clean environment. Then medicines poor people can't afford. We have to have cheap medicines. Agriculture is another problem. Facilities for science education. At basic level, so, and participation of women, because women form 50% of the population. So girls should come forward and contribute equally. Innovate. Now, I will take some examples. First, I'll take agriculture. This is just to tell you that in case whatever is your field of interest, please know whatever is happening now at global level and what sort of thing you can contribute. Now, if we come to agriculture, because agriculture is our main field of this thing for India, changes in agricultural, old traditions are very much needed now. So genetic engineering is one, because genetic engineering can improve plant varieties, plant products, and it can help you in many ways. Then bees and drones. Then artificial intelligence, automation, and Internet of Things. Blockchain technology, another technology now coming where thousands of servers will be connected, and any using that network will have a key to know the latest information. Urban agriculture, vertical farming, because now land population is increasing, land size is not increasing. So we have to think about soil-less farming. So these things are now coming on a big way. Now, what India needs in agriculture, we need genetically engineered plants, transgenic plants, they are known as, which are more resistant to diseases, insects, and we need weed killers, and we need, because water is another problem, so we need such plants which need less water, especially rice. Rice is our main crop, and that needs a lot of water. You know that 70% of the world's fresh water is used for irrigation. So that is our problem. We have to think about varieties with much less water. And a lot of research now is being done in the country for developing different genetically modified products. Then a lot of land is lying which is infertile. Now you have to think about methods of converting into fertile land. So for that, bacteria, for nitrogen fixation, that has to be done. Then vaccines. During this COVID time, all of us have learned that most of our population, especially illiterate population, they are very much hesitant to have vaccines. No, and they think that something else will happen. So the best way out is to put antibodies into foods, which has been done in the past. Like smallpox antibody was put in bananas, potatoes, tomatoes, lettuce, rice, whatever, in food materials. So people will eat and they will be free from this thing. I mean, they'll have antibodies. So women-friendly tools for agriculture, because now most of the young people from rural areas, they are coming to cities for white-collar jobs. And I think agriculture is left mostly to women. So as engineers, you can think about making tools which are women-friendly. Now, we have to think about our farmers so that their income increases and create employment in rural areas for women as well as for farmers. Now, for biotechnology, I think for green biotechnology, we have mainly two issues. One is to grow genetically modified foods. Then fuels, biofuels. I think all of you know that energy, alternative energy sources, they are the main need for future. So we have to develop some biofuels also as alternative energy sources. So genetic engineering is for information that this is change, alteration of genetic code by artificial means, and therefore different from traditional selective breeding. पहले होता था एक प्लांट को दूसरे से क्रॉस करके they used to have new varieties, but now and it was not very definite that which quality of the plant the offspring will acquire. But through genetic engineering, we know because that particular gene is put into the plant, so we know we can have the desired change. So genetic engineering is important. These are some examples. Now, you know, tomatoes are grown on hills in under snow, which was never possible. We have corn, which is now not infected with any insect. Then you know fish which survives under several feet of ice, you know. So gene from that, how they survive, that is very fascinating. So gene which is frost resistant in fish, that has been isolated and put in several food products, so they can be grown in areas where there is snowfall all over the year. Apple is one example. You know, apple, we earlier used to think that only in cold climate, only in Kashmir or Almora or Himalayas, you know. But now apple is being grown all over India at temperatures more than 40 degrees. In your institute also, you can see in IIIT, there are 100 plants of apple, that Harman variety, which is growing, which is giving fruits. So
Near
that is
CC2, ma'am. Near
yeah.
CC2.
Hello?
Yeah, just I'm the near CC2. This all these apples are planted.
Yeah. You can see that and everywhere, and all over the campus.
Yeah, and that too in the 40-45 degree temperature they are surviving.
Temperature, it is growing. That is
Yeah.
the marvelous thing genetic engineering is doing. This
Yes,
is
ma'am.
what I want to emphasize. No, so you can do a lot. Now, rice, because paddy, you know, rice, they have done a lot of research now, and rice is growing with least amount of water. So these are the discoveries you have to do, you have to apply. Now, these are some examples of genetically engineered products. We know there is a gene in human, that is alpha-1 antitrypsin, which protects lungs from different diseases. And this gene has been put in sheep. Now, from sheep's milk, the drug can be isolated. So just see, I mean, things are. Another example is of chicken. The non vegetarians, you know, they like to eat chicken leg, you know, but feathers are of no use. So with genetic engineering, they have produced a chicken with 4 legs and no wings. Now they have creating a goat with spider genes. Spider, you know, you will be surprised to know that ये जो मकड़ी जाल बनाती है, कितनी strength होती है उसमें, you know. So that particular gene has been put in goat, and from goat milk you can produce silk. So these are some wonders, you know, fascinations in science. Now the possible benefits are because you can develop plant varieties which are frost resistant, disease resistant, flood resistant, insect pest resistant, drought resistant, weed herbicide tolerant. So many things can be done. No. Now tomatoes, you know, earlier 2 दिन रखते थे खराब हो जाता था. Now these such varieties are coming which have long shelf life. बहुत दिन तक रखे रहिए, खराब नहीं होगा. Enhanced nutritional medicinal value, food designed to meet specific nutritional goals. So all these are benefits of genetically modified. Now I'm coming to biofuels. Biofuels, you know, you all of you know that mineral petrol, जो ये petroleum मिलता है, mineral petroleum, that is long chain hydrocarbons. So oils, vegetable oils also have the same long chain, but they have at the end an ester group. So what they are doing transesterification and converting these compounds to biofuels. तो biofuels में आप देखोगे कि B100 means only pure biofuel is used. देन B10, B20 ऐसे भी हैं जो कि मिक्स करके यूज होते हैं। लेकिन अगर B100 यूज करना है तो इंजन का थोड़ा सा, क्योंकि ये लो टेम्परेचर में फ्रीज होने लगते हैं, सो द इंजन स्टाइल हैज टू बी चेंज्ड. Anyway, the main thing here is that plants, they catch solar energy. And you know that chlorophyll and many other compounds are formed with the help of solar energy. So we have to see that now people, what they are doing, they are mimicking that process of energy capture and in order to use it for other alternative purposes. So this is another field of research. Drones and labor-intensive tools. In your institute also, I think the two students, they have made a drone and they have started a startup company. I am really happy to say that along with doing PhD, they are doing marvelous job. These drones are of great use for agriculture because they will be great help to our farmers, because they are capable of autonomous flight over vast distances, and they have proven to deliver greater efficiency and higher returns for farmers. Now, farmers don't have to spray the pesticides or measure the requirement of the soil for fertilizers, or else see what disease is catching their crop, because drone has cameras, and if a drone flies over a field, it can take photographs of the crops, which can be sent to laboratories and tested. If any disease is coming, then corresponding treatment can be given. There are so many things, which these drones can help the farmers. Now, there is a team at Harvard University School of Engineering and Applied Sciences that have successfully tested an autonomous robotic bug that can fly. And there are bionic bees, small bees of the size of housefly. They are used, autonomously used for pollination. Pollination, that is, you can sort of do it, that traditional breeding, what you call as traditional crossing, So that can be done with the help of bionic bees. So these are some of the inventions which are really of great use to farmers. Now, artificial intelligence is now being used in agriculture. Agriculture is rapidly adopting artificial intelligence, machine learning, both in terms of agricultural products and in field farming techniques. Do you know that Microsoft is working with more than 175 farmers in Andhra Pradesh, and they are providing advisory services for sowing, land fertilizer, and so many things. And as a result, the 30% higher production has been resulted. So that is what artificial intelligence can do. These new technologies are going to help the farmers. They promise revolutionary change for smallholder listing. Then, satellite imaging, you must have heard about remote sensing, proximity sensing. Sensors are being used for assessing the condition of the soil, condition of the crop as such. Blockchain apps. Blockchain means, thousands and thousands of servers are connected all over the globe with special keys given to the users. And anytime, just on one click, you can know the latest information. Wonderful things are being done. They are optimizing food chains, increase access to nutritious foods, reduce food loss. So many things, you can help in agriculture. So intensive training too, but, in India, we have to give digital skills to farmers. So that also some of you can do as social work, that teaching them the digital skills, how to use it. Telemedicine is another one. Village people, they should know about these. So just briefly, I will give you this thing in health and medicine also, because Artificial intelligence, in silico methods are doing wonders in medicine, health, drug discovery, production, pharmacogenomics, pharmacoinformatics. They are all pharmacology through genomics, through informatics. So genetic screening. Now in time of COVID, so many diagnostic methods, quick diagnostic methods have come. Now, future of drug development depends on areas. All of you must know the names of these areas: proteomics, genomics, transcriptomics, systems biology, array technology, nanobiotechnology. All these are coming in a big way. Basis of array technologies, आप जानते हो DNA में complementary bases होते हैं, and they are used for number of these things. Antisense stem cell technology. These are all future areas, Nanotechnology is doing wonderful. Nanotechnology is there in your institute also. And wonderful things can be done through nanotechnology. Now, coming to precision medicine, we human beings, genetically, we are same 99.9%. You will be surprised to know that the diversity in human race, because every person looks different, that is only 0.1%. So the drug companies are interested only in that 0.1%. So many drugs, sometimes you find that you take drugs, but they don't help. And sometimes they help. So drugs only work on 30% of human population. Extreme cases में होता ही नहीं है. कभी-कभी उसका side effect भी हो जाता है. And कभी नहीं ठीक होता, कभी ठीक होता है. So what is all this? Here only your in silico drug design is helping a lot. Medical achievement, पहले क्या होता था? At least 3 to 4 years for one drug. Sometimes 7-8 years तक लग जाते थे एक ड्रग को मार्केट में आने में. Now with the help of artificial intelligence, you are having, in silico methods are helping for drug designing, drug discovery, everything. This is an example that only in 46 days, a new drug was designed, synthesized, validated, and FDA approved in 46 days instead of minimum 3 years hota tha, 2 to 3 years. So how much time saving is there? I just wanted to tell you, through this picture, you can see here 7 people, they are having colon cancer on your left. Colon cancer, and same drug is given to any doctor who goes, anybody goes with colon cancer, they will give just one drug. But you know what happens? Only 3 will be cured, 3 will have no effect, and 1 may have some reverse effect. No. Now, day of precision medicine has come. Precision medicine means that genetic profile pata hona chahiye. Genetic profile of every person is tested. So different drugs are given according to genetic profile when 100% cure will be done. डोज आप जानते हैं, डॉक्टर बताते हैं ना, 4 घंटे बाद लीजिए, 6 घंटे बाद लीजिए. What is this? Why should you repeat the dose? One dose should be enough. So it depends on your genetic profile. Some people have cured with normal dose, some have lower dose, some are, some they don't respond at all. There are various these things. So this is precision medicine ka zamana hai. Now in future, just like you have identity cards, everyone will have a identity of genetic identity card. No, with that they will go to doctors, and drug companies will collect this genetic know-how, and they will make tailor-made medicines. This is pharmacogenomics. So if patients go to a doctor with, say, high blood pressure, they won't give the same medicine just like at present. They will give a different medicine to different person, depending upon the genetic profile. So a day is very soon coming when patients with cancer will go to a doctor, and they will not prescribe drug based on morphology of cancer, but they will look at the gene expression of that and then give a precise medicine. Now, just briefly about nanotechnology, what is nano doing? Nano is, they are invisible particles to human eye. You can't see with human eye less than 0.2 nanometers. So nanometer is 1 billionth of a meter, 10 to the power minus 9. So this is microscopic scale, atoms and molecules are also the same size. So very small at atomic level. Now there are many, many applications of nanomaterials. They make medicines more effective. They can target drugs to the wherever it is needed, not to the normal cells. So avoiding side effects. There are lots of biomedical applications, diagnostics, contrast imaging जैसे ultrasound है, आपका X-ray है, MRI है, इसमें कई दफा बहुत blurred images आती हैं, तो आपको diagnostics में help करते हैं. Yeah, they are good catalysts because if you go on dividing a substance to nanoscale, the surface will increase. So they are good catalysts and good adsorbents. They are purifiers. You can use it for water purification also. There are electromagnetic applications of ferroelectricity, piezoelectricity. Piezo means वो vibrational compression से electricity होता है. और ये non-conducting is ferroelectricity, magnetism, energy storage, solar energy. We in India should go for solar energy now. Sensing, gas separation, water treatment, fuel cells, electrophotonic nano devices. There are so many applications. This is very interesting. Leonard Edelman, he's a professor of computer science and molecular biology at University of South California. He says that life can be equated with computation. Just imagine 1 gram of DNA can store as much information as a trillion compact disks. Just imagine. William Gelbart is at Harvard University. He says that with our new ways of harvesting massive data, mega data abhi mil raha hai, we have to figure out what to do with them and how to learn with them. So you have to take IT help. So here I must congratulate all of you. You have come to an IT institution where IT can be applied to so many things, life processes. Life science versus computer science. Computer science provided highly useful tools for not only collecting, exchanging, analyzing data, modeling simulation of data, finding right data structure or algorithms can give answers to life science problems. Computer science algorithms make it possible to put together vast amount of data from sequencing machines. That is what is going on in research now. They are collecting mega data analysis, and this computer science computational paradigm, they have shaped new modes of inquiry for life sciences. Artificial intelligence has been used for COVID-19 therapy. During COVID, people have invested really numerous technologies like Lit COVID, COVID NMA project. These are different projects, and these workers, co-workers, they in last year, they have presented a novel fully automated platform that is known as RiskClick AI. ये critical data driven tool है pharmacology का therapy development. These are going to help in further this thing also, not only in case of COVID. So this tool optimizes protocol in short time, maximizes likelihood of success. Authors have used it to get COVID-19 scientific evidence in real time. Now, this tool is able to find COVID-19 references. I mean, just one click, you can get any reference you want. So it has become a very useful alternative assistant to scientists who are fighting with COVID pandemic. Now, artificial intelligence, this is best strategy to seek the most relevant scientific evidence in minimum amount of time. Performance is enhanced, errors are reduced, and so many types of them. Another interesting thing, synthetic biology techniques have become more powerful. Researchers are anticipating a future in which the design of, you know about electronic circuits. Now, similar to that, similar to integrated circuits, there will be biological circuits. Because now systems biology has come. We know about all different pathways. So we can, scientists can create these circuits, biological circuits. Nielsen is another name, famous name. He describes what is essentially a programming language to design computational circuits in living cells. So what are overall objectives? We want science and technology so as to sustain science and technology in future, specifically for our own country, to enable the country to develop. The government should develop, government is already doing, but they should develop policies in information technology, biotechnology, biosafety according to our own needs. Our country needs are different from other countries, so we should do accordingly. To foster communication between scientists, policymakers, biosafety regulatory officials, private sector में nationally and regionally. Now, and to promote collaboration, initiate regional collaborative projects in IT, biotechnology, biosafety, risk assessment, risk management, related policy development. All these have to be done to address key challenges, and a lot of things are already being done. So with this, I thank you for your patient listening.
Thank you, ma'am. So now the floor is open for any discussion. So if any one of you have any question or any doubt, so ma'am is here. You can just have some time to clarify all your doubts or any question if it is coming to your mind. So please feel free to ask to madam. Anyone having any question, query, or doubt or clarification, or any points you want to add or anything. Shrestha Sharma has raised. Yes, Shrestha, please unmute yourself and speak out.
Good morning, ma'am. Good morning, sir. Ma'am, my question is, since my father is, he is a scholar in Ayurveda, and he's it's himself practicing Ayurvedic practice. So, ma'am, my doubt is, since we all have different genetic codes, ma'am, how it was possible years back for people like Patanjali and different scholars to write a particular way to cure a particular disease with a certain medicines? Ma'am, how they were able to crack the final code so that we can be cured with a certain process only?
Oh, that's a very good question. And I think you have raised a very important thing. Now, Ayurveda, we have traditional knowledge in Ayurveda that is based on lot of experience, because our Ayurveda is about 5,000 years old and allopathy is only a few hundred years old. So based on experience, they prescribe medicines, but what is needed in Ayurveda today, because they mostly use decoctions and they are mixtures. Why mixtures were used? Because they were not very sure about the exact mechanism of every chemical compound as a drug, and therefore they used to give mixtures just in order to neutralize the whole effect. The basic of Ayurveda is to enhance immunity, not to cure, because they say that it is better to enhance immunity so that you don't catch the infection. And most of the Ayurvedic drugs, they enhance immunity. They don't cure. What is needed? I have worked a lot on Ayurveda and I would really like to speak about it. I gave a lecture in Michigan University in a hospital where about 300 doctors were present. And the net conclusion of that meeting was that Ayurvedic mixtures, these decoctions, should be worked. Each component of each decoction should be worked on basis on systems biology, the mechanism, and how it is acting. So the modern researchers will give a real view of the net effect of these Ayurvedic. Lot of research is needed. And this is what you people can do now.
So I hope this clarifies your doubt. One more person have raised his hand. I could not see your name. Just unmute yourself and ask your query or question.
Good morning, ma'am. Good morning, sir.
And please open your camera also, because we also wanted to see your faces. Anyway, please carry on.
Good morning, ma'am. Good morning, sir. I wanted to ask to ma'am that I have recently heard about ashwagandha. In US, they are doing a research in which they have find out that ashwagandha, which is a very important Ayurvedic medicine, it helps in curing cancer. It increases stamina, and it can also be used as a very good immunity booster. And very recently, they have find out that ashwagandha possesses all these properties. But in Ayurveda, we have been using ashwagandha for since a long time. In the Vedas, even it is mentioned about the benefits of ashwagandha. So, ma'am, I wanted to ask: is the research which is going on, especially relating to ashwagandha or Indian ginseng, as they call it, is it all true or not?
It is very true. And you have raised another leading to another problem in Ayurveda. And I can tell you that ashwagandha, for example, it has been exhaustively worked. And you are right that it has been reported for various things, and that you will find for other Ayurvedic drugs also. That one molecule they describe for so many things, But the problem here is that what I think that plants produce these metabolites for their own defense, and plant genetics is bit different from human genetics. And as I have talked about precision medicine, I think this is true that not only ashwagandha, but other Ayurvedic all molecules also work for many things. They enhance immunity, they work for, they are very good. But the thing is that these molecules are meant for defense of plants. So they have to be modified according to genetics of humans. That has to be done. A little modification according to our own genetics. And those molecules will be definitely what I really feel that they will be much more effective precisely than what our Ayurvedic medicines at present are. So we have to work towards it. What I found that since now many of the mechanisms of this thing are known. We know human genetics now very well. We know the targets. We know the pathways. So I think we are the best, this thing, there should be a lot of research chemically modifying these molecules based on in silico results to make them more effective for human this thing. That is what is wanted. I hope it is clear.
Thank you, ma'am. Thank you very much.
So, thank you, ma'am, for your enlightening and, in fact, truly a thought-provoking speech. So definitely, this is inspirational, and it will giving a new direction to our young researchers and young people who will be now coming to this higher education. So definitely, thank you, ma'am, for giving your time in the midst of your busy schedule. And at this age also, you are so active and so energetic, ma'am. So thank you, ma'am, actually.
Thank you. Thank you. You are always welcome. Yeah.
Thank you, ma'am. So thank you, ma'am. So friends, we shall have a quick break of 5 minutes, and after that we shall we'll resume the session once again for the next technical session that will be by Professor Shekhar Verma. So thank you, ma'am.
Thank you.